In a cubic polynomial, gx is divisible by x plus 1, so we have two instant findings. The first finding is if we put a suitable x, which is -1, then the remainder will give you 0. That's the meaning of divisible. Another implication is in case that we are going to build up the gx original function, then we can write is x plus 1 times something. However, that's something we don't know much about that. Only thing we know is cubic divided by degree power of 1, then should be something x power of 2 is left. So if it is needed, we may write in this way. So similar reason, when they say gx is divided by x squared minus 1, then the remainder is kx minus 5. We can also use the remainder theorem. G something should equal to remainder. Now the problem is what is the suitable x you have to put inside to make that value equal to remainder. So in a draft, we are going to write when the divisor becomes 0. We are finding the suitable x to make the divisor become 0. So x squared equal to 1 and x is equal to positive 1 or negative 1. That means we can draw two conclusions. So the first conclusion here, when x is equal to positive 1, then we have g positive 1 is equal to the remainder. The remainder is kx minus 5. And don't forget, you already give a constraint for this situation is x is equal to positive 1. So this is no longer a variable but a fixed value. You should replace x by 1 also here. So therefore g1 is k minus 5. We do the same thing for second case. So when x equal to -1, because we have one more suitable x, now is g -1 is equal to k times x, x is -1 in this case, minus 5. So basically we have this finding, then we just write here first. On the other hand, if we are going to build up our original function, then we can write gx is equal to x squared minus 1 times something, and also the non-divisible part, that means the remainder at the back. Again, we don't know exactly what is the quotient here, but by the wording cubic and also divide by x power of 2, then I know that x power of 1 should be left. So it should be how something x plus something. We are not sure at this moment, and maybe this is not useful, just bear in mind. So find out k. For the blue implication, it seems like it's not that useful at this moment, but we have g -1 and g -1 which are the same. So we can draw the conclusion. G -1 is equal to -k minus 5 and also equal to 0. So this equal to this equal to this equal to this. And then of course we just focus on this part. Therefore -k minus 5 equal to 0. K is equal to -5. Afterward, the question gives one more information. X minus 2 is also a factor, so you may write down G2 is equal to 0. And then when Gx is divided by x, the remainder is -4. So you have to write down the implication again. When you put suitable x to make divisor become 0, that means just 0. Then the remainder is -4. We have these two more informations. And you are going to solve gx equal to 0 and check whether they are all integers. To do so, then of course you have to know the full picture of gx. At this moment, you only know it's maybe like this or maybe like this. So basically, you can let this one be ax plus b. And then make it fulfill these two requirements, then maybe you have two equations in order to solve the value of a and also b here. That means you can write gx is equal to x squared minus 1 times ax plus b, and then minus 5x minus 5. Because we already know the value of k, so because you're not sure, so you just simply let it become this format. And then by using this one, you have the first equation. By using this one, you have the second equation. So if you make good use of this result, you have the first equation, you have the second equation, and obviously 0a, so you don't have to consider a, you just have an equation about b, then you can easily solve the value of b. This is one of the method, but to be honest, this is not very good method. It's because after you get the value of a and b, you still have to expand it, and also you have to factorize it. It's quite time consuming. Therefore, the smartest method is, because you already know two factor of them, including the beginning we have x plus 1 and also we have x minus 2. So we can write x plus 1 times x minus 2 and also times something. For a cubic polynomial, divided by x power 1 divided by another x power 1, so x power 1 should be left. Then it should be something x plus something, without any remainder because both of them are factor. So we use the same logic, we let it be ax plus b. Beware that because we have different definitions, so this a and b are not the same as the previous case. The rest of the calculation are similar, so we consider G2 is wasting time to consider because it will make the whole thing become 0. And then so we consider G0 equal to negative 4. 0 plus 1 times 0 minus 2 and then plus 0 a plus b is negative 4. So negative 2 times b here is equal to negative 4, and then we get b is equal to positive 2 very quickly. Obviously, we need one more information in order to get the value of a. So we search here. We already used this one, and also this one, these two let us able to let in factor format. So this one already used. Now the only one we didn't use is g positive 1. So maybe we try g positive 1 equal to k, which is negative 5 minus 5. 1 plus 1 bracket times 1 minus 2 bracket and then times a plus b. X is replaced by 1, so therefore 1a here. Negative 2 times a plus 2 is equal to negative 10, divide both sides by negative 2. So therefore a is equal to 3. Now we write the whole equations. We are going to solve gx equal to 0. We have full picture of gx, x plus 1, x minus 2, and the last factor should be a 3x plus b, that means 2. To solve it, we have x equal to negative 1, or x equal to 2, or x is equal to negative 2 over 3. The first two are integers, but the last one is not integers, so we have to disagree the claim. They ask you the claim is that correct, then the answer is incorrect.